All right, guys. Chapter 6. All right, chapter 6. Please pay attention. Now I'll try to summarize for you section 1 in a quick and easy way. Section 1 goes like this. This is the summary you need to learn. Say you got a payment of 1,000 to make it easy, and you got some interest rate I don't know, 5%. We got 4 types or ways of calculation. Calculation 1 is ordinary annuity. And the other one is annuity due, okay? And then you have to do either present value or future value. And it's just a straightforward calculation. So all you need to do is be extra careful. Am I asking you present value of ordinary annuity? Am I asking you for future value of ordinary annuity? Respectively, present value annuity due and future value of annuity due. And these are the 4 primary problems to solve. Okay. Next, you need to solve, if you're given any of these values, you may have to solve for the payment. How much is the monthly payment? Let's say on a 60-month loan. Traditionally, car loans were originally made for 3 years. As Americans grew poorer, they had to extend the loan for 5 years. And as they got impoverished, they extended the loan for 7 years. All right, they extended the loan because they got student loans to pay, they got mortgage loans to pay, they got furniture loans to pay, they got credit card loans to pay. So there's not much money left. So the payment is the one question that you can ask. The other question may be, how many periods? Could be months, could be years, okay? For example, I want to buy a house for $100,000 and I can afford $1,000 payments. How long would it take? Okay. Sometimes the question is the interest rate. What is the interest rate? For example, an insurer will offer you a product, and that product will be, insurance product, will have some kind of a return. We call this implicit return, and later on we'll start, it's called internal rate of return. I can write it on it now, but you don't need to know it now when you get to project management later on, and we'll study about it. So, tell me the payment, tell me this, tell me that. And sometimes, a lot of times, the calculation gets simpler or more complicated with that one thing called down payment, where we make a payment in period 0, that will be for the house, and then if you need a house for $100,000 and you make a down payment of 20, you subtract it off right away, so it becomes $80,000 is the loan. But sometimes you have a down payment on some insurance product, and then every month you're keeping, and then the question is how much money you accumulate at the end. And I'll be doing this a little later. So this is basically section 1, fairly straightforward. You got these 4 types of problems. Now notice, for each type of problem, you may have to calculate the payment, okay? For each type of problem, you may have to calculate the number of periods. Again, for each type of problem, you have to calculate the interest rate. Or if these 3 are given, you may have to calculate whichever. It's very important that you're careful to watch about the setup of your calculator so that when you switch between problems of ordinary annuity and annuity due, you don't use the old setting, let's say, of ordinary annuity. You have to switch every time, okay? Because usually calculators will remember the last value from the last problem, okay? That's how they work, okay? If it's a software, if you're using some kind of a software, maybe it will have a drop down, and the drop down will say ordinary annuity or annuity due. You have to be sure about that part, okay? So when you're practicing now, that will be it. And if I remember, that's pretty much section 1, the future value, the payment, solving for the interest rate, solving for the number of period, the present value. Okay, well, that's the way it is. So, last time I did mention, it works exactly the same as the amortized loan. Amortized loan is actually the practical application, what you will need to do if you're, let's say, working in a bank. A bank will usually do loans, and almost always the loans will be amortized, okay? And that's the most practical application that you will have, okay? And now, later on, probably I may make up for quiz number 3 a problem similar to the practical calculation. It's just the multi-step of these problems is you borrowed money, let's say 80,000, or I'll give you the example of my brother's house, $330,000. He borrowed at 8%, and then interest rate falls to 6%, so you refinance. Now, you borrowed at 6%, and there are 2 questions. How much his monthly payment can fall? Or the other question is how much he can shorten his period of payments. In other words, he will keep the same payment, but now instead of 30 years, he would maybe pay it off in 20. Okay? Or an alternative question, just a 2-step problem is, okay, you're making your house payments 30 years, let's say 25 years are left at 8%, and how low interest rates will have to fall so that you cut the payments in half, or that you cut the period in half. So instead of remaining 25 years, you can pay it off in 12 and a half years. Okay? So this is essentially mixing up 2 problems. You calculate the one problem, you calculate the payment, and then you use, let's say, half the payment and recalculate the new interest rate, okay? All right. Next will be, I did the annuity due. Next is just 6. 2. Perpetuity. And perpetuity, is that how they call it? Yeah, that's how they call it. And sometimes back in the old days, but it's not standard, and people may get confused, they called it continuity. But that's not the standard, it's not acceptable. Perpetuity is simply, okay, that's for you, page 189. Is simply a series, infinite series of payments. Payments without end. It's a series of payments without maturity. And the first, simple perpetuity. Simple perpetuity. The payments are always the same. For example, $100, $100, $100, $100, and this without end. And the other one is called growing perpetuity. In a growing perpetuity, payments will grow at a particular rate. For example, 1%. It's very tricky to calculate off 1%, but the first payment is like 100. Second payment's going to be 101. That's 1% bigger. Second payment's going to be 102. Point little something. Next one's going to be 103 point little something. Next one's going to be 104. So these are growing at roughly 1%. Now, if you're having a 2%, the first one's going to be 100. Second one's going to be 102. The third one's going to be 104, a little something. Okay? Next one's going to be 106 and a few pennies. Okay? Next one's going to be 108 and a few pennies. Okay? So they grow. This grows at 1%. This grows at 2%. So we call this growth rate. Growth, DH. Rate. Okay. So, how do we get the present value? Obviously, there is no future value. You can do the future value by calculating the present value and then moving it as many periods as you need. So, for all of these perpetuity, the question is find or calculate the present value. So, present value is simply the perpetuity. This is the payment. We denoted with letter C, standing for coupon, C. So it becomes C0. That's the current payment at period 0. Sometimes you ignore it, okay, depending, does it have an initial payment or no, whether it's a perpetuity due or not. Plus becomes C1, 1 plus R. Plus C2, 1 plus, C1, C0, again, C0 equal to C1 equal to C2, okay, I'll rewrite it, plus R squared, C3, 1 plus R, third, plus dot dot dot, plus Cn, 1 plus R, n plus dot dot dot, okay? And then C0 equal to C3 equal dot 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 equal to Cn equal dot 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 equal to C, which is C, just the coupon, the payment, okay? So this is just a simple geometric series, and a geometric series, if it's infinite, becomes simply C over R. If it's R, sometimes you gotta check and see the text uses the letter I. So in finance, we sometimes use R for interest rate, and sometimes we use I for We usually use the one letter, we usually use the other letter. These are the two common letters. Some authors like one, some authors like the other letter. Okay? We use these interchangeably. Alright, so this is so. Now the only question you gotta be aware of, what happens to the zero payment? Is there a zero payment? In this problem, is there a zero payment according to the textbook or not? With this answer. Let's take a look. PV, present value, is equals to this. Let's take a look. We gotta see. Okay, we'll check that later. I think there is. Okay, I'm gonna find out later. Alright, I'm gonna solve the problems later. I'm gonna find out about it. So that's it. That's all there is to it. This is the, let's rewrite it, PV. Alright, so in these problems, you're always very careful about what happens with the first payment. Is it due or is it ordinary? Okay. And if there is a growth rate, it is a standard mathematics where for a growth rate becomes like this. Present value is C R minus G. R minus G. Okay? So, for example, C is equal to $100 and again, I'm switching between I and R. It's the same thing. Let's say at 10%, the present value will be 1,000. At interest rate of 5%, the present value will be Is it? Calculator, iToys, 2,000. Is it or not? Yes. Alright, if I is 2%, the perpetuity will be worth 5,000. If I is 1%, very unlikely it's going to be worth 10,000. But if interest rate is, let's say, 20%, the perpetuity will be worth only $500. So, perpetuities are very, very easy to calculate. Alright, now, perpetuity, let's say it's 10%, and now, well, I'm running out of space. I'll do it backward. Okay, I'll do it backward. Like this. I'll do it here. Like this. Here, I write G equal to 0. Now, I'm going to do this trick and say G equal to 1%. Growth is here, 0%. It grows at 1%. What's the new value? iToy? I'm expecting someone to throw a number at me. See, let me try and guess. I'll make a wild guess. Like 1, 1, 1, 1. Anybody? Would the value be interest rate 10% and growth rate at 1%? What's the present value? Huh? Oh, 1111.11. Is it like that? Or, Oh, 100? 1011? 111.11. Okay, 1111.11. Is it like this?
Yes.
Alright, okay, next one. You have a 5%. It was 2,000. What's the new number? Let me try my guess, it's called old school. Old school is like 2,500. What's iToy say? What's the...
Yeah, it's the same as yours.
Okay, well, lucky me. Well, next one is even easier. Old school says... Is there anybody else? It's just me, old school here. Huh? Oh, yeah, 10,000. And next one. Next one. 1% discount rate. 1% growth rate. Infinite. Means it is impossible. Guys, please pay attention. Alright. It is impossible to grow faster than the discount rate. It is impossible. If you grow faster, it means you're probably not growing faster, or there's something broken with the discount rate. The discount rate is incorrect. But it is impossible in the real world to grow faster than the discount rate. Okay? The result eventually is infinity. And here, from 20, what is it going to be? 500 and what?
26.
506?
No, 526.
Oh, 526.31. Okay, something. XX 31. All right? That's for G equal to 1. All right? Okay? One last exercise. G equal 2. What's going on, guys? G equal to 2. The first one, a 10%, becomes 1,000 divided by 8% will be 1,250. Okay, I'll take that one. Next one, a 5 will become old school, 333.33. Is it?
Yes.
Okay, I'm getting lucky. And a 2% is infinite to impossible. This is infinite to impossible. And over here, 20 minus 2, 18 is going to be, I don't know, 550?
555.55.
Okay, oh, 555. Okay, well, if we got to round up, we got to round up to 6. All right, this is good enough? Okay. All right. That luckily completes my section 2. All right, and now section 3, 6, 3. Irregular cash flows. That's what you're likely going to get on the final exam. Or quiz number 3 is an irregular cash flow. Well, they could be irregular in 1,000,000 different ways, okay? For example, the first few payments may be 300, 300, 300, and then they switch to 600, 600, 600, and then, I don't know, maybe 12 payments here, and 3 payments here. Alright? This particular is a simple sum of 2 annuities. This is annuity 1, and this is annuity 2. Okay? So that's one way. Let me see what else they got. Okay, well, that's page 193. And in 193, when you look, they have a payment similar to what I did, which is 5, 5, 5, and then 8, 8, 8. 8, 8, dot, 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 8. The first are 3. And how much are on the second problem? The second one. How many payments? 4. Oh. Number 4 is actually minus. Number 4 is minus. And then number 5, 6, whatever is this. Well, if that's the case, notice. Guys, pay attention here. I can't do minus, plus, plus, plus. That's improper. I gotta do only the pluses here, okay? So, this becomes 1 payment. How many payments are the last 800s? How many? 6. All right. So, you will calculate present value of this. That's going to be 1 present value. You're going to calculate the present value of this. And then you're going to calculate the present value of this. Okay? Now, here, this one and this one is a simple, easy trick. You calculate the present value as in you make these 6 payments. And when you calculate, you will actually move it 4 periods backward. Okay? So, you calculate these present value here, and then you discount 4 periods back. This one, there is no calculation. It's simply discount 3 periods. Or, okay, this is actually 1, 2, 3, 4. This one, you discount 4. This one, you discount 5 periods back. So, you take all of these, you discount, you calculate, and then you discount 5 periods back. You take this one, discount 4 periods back, and you take this one. So, you may have to decompose it into a number of payments. Sometimes they say the following. Well, you got a payment of 100, then it's 200, then it's 300, 400, and then it stabilizes to 400. For example, you're running a hotel early on, you don't have advertising, the hotel is at approximately 20% capacity, here it's 40% capacity, here is at 60% capacity, and in the long run, you expect to run a hotel at 80% capacity. Running at 100 is like impossible in the real world. But on average, you're going to be averaging this. So, this is a complex cash flow, and then you value the hotel to be the present value of this one, plus the present value of this one, plus the present value of this one, and then you take this perpetuity, you calculate its present value, and then bring it back 4 periods early. Now, let me finish for today with doing the simplest of all finance calculations, which is calculate the value of a house or the value of an apartment. How do we value an apartment? Well, the first trick is you need to know the interest rate, okay? What is a normal interest rate? All right, what's a normal interest rate? Normal interest rates over the last 200 or 300 years have been about 8 to 10%. Okay? 8% to 10%. Interest rates would be high when interest rates are 12 to 18%. And historically, low interest rates will be 5 to 8. Okay, this is a typical structure. Now, currently they're even lower simply because we have the lowest interest rates in the last 5,000 years of recorded history of interest rates. These times are abnormal times, okay? So, let's say a house has what will be a typical average rent payment, okay, of a house or of an apartment here. Let's say in town, Phnom Penh. What will be an average, some kind of middle average. And then we're going to do some calculation based on it. What will be an average a house or apartment rent? 350 or 4. Well, let's do 4 for slightly easier calculation. Okay, so rent. Rent is the same as payment. Let's make it 400. Now, the tricky part is that when you do this, you need to convert these interest rates, you need to convert them to monthly payments. But for the moment, we'll just ignore. Then we'll check to see how much is the error. Okay, we're going to check the error and we're going to make the conversion to the error. The error is going to be tiny. All right, so if the payment is 400, what is this range? What is this range? The house should cost about how much? All right, here is a simple trick. Okay, let me tell you the simple trick. If 400 is the monthly payment will translate to an annual payment of how much? 4,800. Well, if you take the interest on that, it's going to be just about 5,000 with interest. And now you can use the 5,000 of annual payment to calculate. Okay. So how much will be the house on a 10%? Normal price will be 50,000 to, what's the other number in the range? Guys, got it? Why are you just staring and sleeping? You gotta get the little calculator and calculate. But it takes about 3 seconds. What's the other number? Can you give me a number? You say 400 is the monthly payment. And therefore the annual payment, okay, this is monthly. This is annual. And then you have a perpetuity. Annual of 5,000, a 10% is 50,000. Well, how much is it 8%? How much is it 8%? Oh, 62, okay. Okay, so this is the normal range. Now, if interest rates are high, what's the price? 40,000? 41 to 41 something to, what's an 18%? 27? 27,000. And at 5%, it will be worth 100,000. And at 8%, it's going to be 62. Okay, so let's draw a picture. Let's draw a picture over here. So this is, let's say, 50,000, okay, 50,000. 100,000. 200,000. Where's the normal range? Normal range is 50 to 60. This will be here, normal. Okay. Here, this range will be associated with this is going to be high interest rates, okay? And somewhere over here is going to be low interest rates, okay? What's the question now? All right, well, that's it. This is what a value of a house. Here, this number here at high interest rates will be about, what did we say? 27, 25. Okay? And it's actually going to be relative to normal interest rates, somewhere over here. Let's change this a little bit like this. Somewhere over here, somewhere in the middle, where interest rates get very low, all of this is a bubble territory. All right, now we're going back to this question. If the original monthly rent is $400 a month, that same property which rents for $400, what is its approximate price these days here? The same property in town that will rent for $400, what's going to be priced at? Is it going to be worth $50,000 or $70,000 or $100,000? What is it priced at today, these days? Yeah, in the same property that will be renting for $400, what is it going to be costing?
50,000. 500,000 at least.
Oh, 500,000? Half a million?
Yeah.
That's amazing. All right. Recalculate. Here's what one of the teachers just told me. The house, well, it's far out, is renting barely for $150. That's what it's barely renting for, because it's far out of town, too far away and all the other stuff. And they're asking $55,000 for sale. What does it look like? How much this house should cost? Should cost about 10 to 15. All right, and it costs 55. That's a 3 times higher bubble. Now, for this one, which he says, if it costs $500,000, it's a 5 times bubble. I still think it's probably costing about $300,000, but you probably know better what the price will be. All right. All this tells you is how crazy the real estate bubble is. And it will also tell you, if it's 300,000, how far it will fall back to normal. So from 3,000 to fall back to normal, it will fall about 5 or 6 times. Okay? When it falls, it may fall in 3 years, it may fall in 20 years. Okay? And it may fall, okay, well that's the next problem for us to solve, okay? We take a break, okay? We take a break and then we do calculations. The first calculation is this. The first calculation is this. You have a crazy bubble of 300,000 US dollars and must deflate to $60,000, but it falls only for 5% a year. So 5% is how much it falls. That's negative 5%. And the question is, how many years it will take for the bubble to deflate? All right? Take 10, 12 minute break.